Thank you very much. It's very exciting to be here in Berlin. So it's a beautiful world we live in. I grew up cutting my teeth on shrink wrap software, where if you found a bug, and occasionally I would write code with bugs in it, you would have to wait until the next release in 3, 6, 12 months to get that bug fix out. Or you'd have to ask all your users to download a patch, and that just didn't exist in the 80s and 90s, early 90s. So in one sense, the web has given us this beautiful world where we can work on stuff and make fixes and do pushes on a daily, hourly, maybe even by minute basis. But we've also entered this minefield, this battlefield, where what we really want, if you think about it, the idea of pushing programs apps at that frequency to everyone in the world is a very challenging problem. And it's especially challenging because we don't want any monolithic organization like Microsoft or Adobe or Google to run that entire environment and ensure its quality and integrity. So we're trying to do this in a very distributed way, an open source way, and that's the cause of many of the problems that we've been talking about this weekend. Inconsistencies, incompatibilities. So a primary way that we can, or a primary weapon we can use in this battle, to carry the metaphor, is sharing the information and experiences and best practices that we have. And so I want to give some credit to the speakers who are here for the conference, to the attendees. There's a very receptive techie audience. That's awesome. I've never been at a tech conference where a speaker got a standing ovation like Ryan got just a little while ago. That was amazing, and that shows how committed people are here, both the speakers and the audience. And then also to the organizers. I know they're going to get up at the end and close this, and I'm sure I'm going to butcher their names, Jan, Olger, and Malte, for pulling this together for a first-time conference. It's just amazing. And I know when they get up, they're not going to compliment themselves and ask for a round of applause, so I'd like to do that now. Oh, I've got some more fun slides. So I'm in an awkward position. I was in this position earlier this week too. I stand between you and the party. But it's just not me standing between you and the party. There's also John Resig. I'm not alone. And what we see here is something that we all need to practice, multiple disciplines, right? So we all know that John is a JavaScript ninja, and he's got some of that going on here. But he's also pulled in the Three Stooges technique of the two-finger eye poke. Right, so two techniques. Often in your development work, you're going to have to employ more than one technique. And then another good buddy of mine couldn't be here today, Dion Ulmer. He had to leave. But he told me that, he gave me this next slide. He said it would help me get a very warm reception when I did my talk. I don't really understand. He said to mention he's from England. Does that make it more relevant? Okay, so let's get into the meat of the talk. If you could memorize this really quick. I don't want to litter all my slides with footnotes, so these are all the footnotes from the slides, and if you do want to find the sources, it'll be pretty obvious where they go. And I skipped over the first slide kind of quick, but you can find these slides on my website right now, stevesouders.com. So a little bit about me. I used to work at Yahoo. I work at Google now. I created Why Slow. I wrote 2 books about web performance. I taught a class on these books at Stanford. I co-chair the Velocity Conference on web performance and operations. I also wrote Hammerhead, Kazillion, SpriteMe, and BrowserScope. I'll talk about some of those later today. I have a blog. Does anyone here read my blog? Okay, keep the hands up. Hands up, keep the hands up. Okay, hold on. Someone said, oh, but they've already got the books. You know, yeah, like I really believe everyone in the room has read the books. Yeah, that was very polite of you to say, make me believe that. So I think the main thing that I contributed to the world of web performance is what I call turning it upside down, turning the focus upside down. I worked for 10 years doing web development on back-end architectures. I ran the My Yahoo team. I worked on Yahoo's user database. Before that, I worked at Lycos and Whoware. Large web companies. And about 5 years ago, I got asked to start a performance group at Yahoo. And that was one of the first times I fired up a packet sniffer. And we've seen a lot of these waterfall charts. So we kind of know what's going on here. But we have a HTML document and then all the other requests that come forward here. And one thing that I'd like to highlight here, I'm not going to talk about it too much more, but if you look at this, we consider, or a lot of my work is on how to download stuff more quickly. Kyle talked about that yesterday for an hour. And if you look here, this person's internet connection is being utilized at most at about 20%, 10 or 20% of its capacity. And so we need to do a lot of work in trying to get that up. It'll never be 100%, but we're never going to have fast web applications until we start utilizing the browser's network connection, at least at the 80% level. So we've got a lot of room for improvement here. That's why I'm very optimistic that the slow performance I experience now surfing the web is fixable. So anyway, the thing I flipped upside down was, you know, in my first 10 years when I wanted to optimize the performance of a website, I would focus on that back-end architecture. And it turns out, in here I'm loading iGoogle with an empty cache in IE7, that only 9% of the overall page load time was the part that I was focusing on. And maybe I could improve that back-end part 10% if I was really successful. So I was going to knock off about 0.9% of the load time of the page. So clearly I wasn't focusing on the long pole in the tent. The long pole in the tent is what I call this front-end part. And this front-end part does include some network traffic, maybe a little bit of server back-end time. But it turns out that these techniques that I evangelize can really have a dramatic improvement on this front-end part. And even like the network part isn't always the culprit. So here we see with a prime cache, there's only 2 requests, the HTML document and some other beacon or ad or something like that. And even with everything cached, the page still has a long load time, reading all of that, all those resources from the browser cache, parsing and applying all the CSS and JavaScript. So what can we do to fix that? So I came up in Why Slow and in my first book with these 14 rules for faster websites. And so I did that work mostly like 2006, 2007. And after the first book came out, I started working and focusing more on the world of Web 2.0 and Ajax and DHTML. And so this book is much more focused on JavaScript. And I've got some chapters contributed by industry experts like Dion and Ben, Doug Crockford, Nicholas Sakis, Nicole, who's here, and talking about CSS, but she and Stoyan, in my mind, are the industry experts on image optimization as well. So they contributed a chapter talking about images. We have all of these best practices, and they've been out there for a while, but I don't know about you, the web still feels slow to me. And so popping up a level, what is it that, you know, in your reaction and your emotional reaction and frustration levels, what is it that makes you feel like a site is slow? So I have a couple examples here I wanted to show. So I actually have videos here. So I hit return. So this is real time, it's not slow motion. And this also isn't on the internet here, right? These are videos I recorded at home on my Comcast cable modem connection at 3 megabits per second down. And that's how long it took to load. Twitter, I love Twitter. I don't use it a lot, but okay. And this was at like, I mean, you know, it's like 1 a.m. when I'm doing these things, you know, like it shouldn't be that slow. Twitter, it's a lovely page. There's like 20 tweets on there. How can that take so long to load that page? Like, you know, to me, there's no excuse for that. Anyone who has Flash in their site will like this one. These guys actually do a pretty good job getting some progressive rendering to go. But the main thing I want to see in the page is in the middle there, and it's the last thing to come in, right? And then the poster child for slow websites. I mean, it looks like I loaded the page 3 times or something, you know. And finally it comes in. So I think what makes these sites slow, what makes sites feel slow, it's pretty obvious. One of the earlier speakers mentioned it, is the lack of progressive rendering, right? I go to the page and it just takes so long before there's any feedback that what I want is actually going to be delivered to me. So here's another, so I'm starting to put a lot more visualizations, graphics, and video in my presentations because I think it makes the point really well. And I want to kind of light the fire under you know, these web companies to focus on making a faster user experience. So this is screen captures done at a half-second interval for the major search providers. And I want to point out here that they're sorted in order of popularity. This might just be in the US. Yeah, I think it is just US. So Google has the most, AOL has the least, and this kind of pattern where things are in the upper right argues very well for my work. It shows that the fastest websites are the most popular, right? So in search, I think it's not surprising that we see that kind of dynamic happening because speed is something that has become a very real competitive advantage, a benefit in the search marketplace. So just where did I get this stuff? I want to highlight webpagetest.org. Here I'll actually, we'll see, well, even if the internet's not working, I captured some pages. So try it out, it's really easy. The AOL guys built this IE plugin, so if you want to, you can plug it into IE and do things live on your desktop. But you can also go to this website and just plug in a URL. You can pick your, they just last week got a location hosted in California. They've got some folks helping them in the UK and New Zealand. You can choose right now just IE7 or 8, different bandwidth speeds. You can say capture a video. You say go. All the results, unless you choose to hide it, are saved. So even if you haven't run anything, you can just go to the test history and click any 2 video results and compare them. And so here I want to play this video. So this guy, Pat Meenan, has written all this code like in the last 2 months for all this video stuff. So you can see here, like, these are loading pretty slow. And you can see there that Bing comes in a little bit faster than Yahoo Search. I think Bing is 3rd right now, but certainly they're fast and they're getting faster. And I think that's a reason that they're catching on more, plus the awesome name change. Live search, Bing, Bing. You know, you gotta love Bing. So yeah, Pat Meenan, a guy after my own heart, just hacked stuff out of his basement. So that's how you can run webpagetest.org. Here's the same thing in news. Notice in news, I had to go to a 1-second interval. And so we see here, this actually argues against my evangelism. We see the fastest one, Google News, is actually 4th in the marketplace. So there's obviously other things that come into play here. Yahoo News was established early on. Maybe they have, I don't know what, more content, a better UI. We see here, number 2, CNN, hasn't even started rendering yet at the 4-second mark, right? Shopping, so this looks a little better for me. Amazon, I think, if you want to look at techniques, look at things like Amazon and MSN and Google Search. These people really know what they're doing. So Amazon has a lot, I think, has a lot of content in their pages, and yet they're very good about flushing their document early, getting progressive rendering of stuff above the fold to happen quickly. Sports, we see that ESPN, even though it starts rendering early, it's one of the last ones to get the meat of the page up there first. The meat of the page is the photo of the Red Sox almost getting into the World Series. And it comes up last on ESPN. So I think the key there's this key pattern that people don't talk about enough, and maybe because it's a little too hand-wavy and not that techy, but I think we had this pendulum where we got into JavaScript and we built these web apps that were really heavy with JavaScript. And when I describe this, I think you'll agree with me that if someone had described this before we started, we would have said, oh yeah, we'll never do that. We got to this point where we downloaded all of this really expensive JavaScript into our pages and then created all of these HTML elements, either via create element or by stitching together a really long string and setting inner HTML, and then the user could actually see the content of the page. That just sounds ridiculous when you say, like, that's how I'm going to build my web app. And so I know properties at Google are doing this, and I talked to other people who are doing it also, trying to get that pendulum to swing back to where it should be, which is to do progressive enhancement, is deliver the meat of the page in HTML rendered on the server side as quickly as possible, right? Defer the JavaScript, don't touch the DOM or touch it as little as possible. And then once you get that meat of the page up in front of the user, you can add the decoration, the JavaScript functionality to enhance the page after the user has the content in front of them. And you do have to worry about race conditions, the user clicking on buttons before it's ready, but those aren't that difficult. Those challenges aren't that difficult to work through. And so if you adopt this pattern of progressively enhancing your pages, you'll get better progressive rendering and I think better user experience. So in doing this, it's really important to focus on JavaScript. Why? So here's some of the Alexa top 10 websites. And what we see is JavaScript dominates the load time of the page. And usually it's disproportional. There's a very small number of JavaScript requests in the page, but it's causing the biggest slowdown in the page. These are all done with IE7. And that's because scripts block, right? The scripts block both downloading and rendering. So here's a hypothetical test case using my Gazillion tool. I have two scripts that take 2 seconds to download, 2 seconds to execute, and then an image, a style sheet, and an iframe that each take 1 second. And in these browsers listed here, we see what happens is when the first script starts downloading, the browser won't do anything else. No other downloads, no other rendering. It will take 2 seconds to download that file, 2 seconds to execute. When all of that is done, it will start the next script, but that will block everything else, all rendering and other resources, until it's done. And then we'll get 2 seconds of execution, and then all the other resources in the page will download together in parallel, which is very cool. And so this is, obviously why one of the why slow rules is to move your JavaScript as low in the page. But also in my new work, I've talked about how to load these scripts in parallel, because I certainly understand, this script might depend on the symbols in this script. So this code has to be parsed and executed after this code. But it's just ridiculous that the browser knows there's 2 scripts, and it doesn't even start downloading this one until it's done parsing and executing this one. There's no excuse for that. And that's why we're seeing in the newer browsers that they've actually added parallel script downloading. And the built-in behavior is that it will download these 2 scripts in parallel, but it will execute this one for 2 seconds and then execute this one for 2 seconds, so you don't get any race conditions, undefined symbol errors. But we see that they're still not good enough. And Kyle, again, highlighted this in his talk. So here, I think I'm in Firefox 3.5, and it will only pull in the style sheet and load that in parallel as well. Whereas what I really want, I want all 3 of these extra resources to be loaded in parallel. And that would make the page 1 second faster in this test case. So how do we make that happen? So even in the newer browsers, we're getting better, and hopefully in the next round of browsers, I already know some of these issues have been fixed in the next round of browsers, but we're going to have IE6 and IE7 for years to come. So even in the newer browsers, it's not as optimal as it could be. We've got IE6 and 7 for years. What can we do about this, about making JavaScript less painful for our pages? One thing is to split the initial download of JavaScript. So here, there's this tool, PageSpeed from Google, that I'll talk about in a minute, that can tell you how much of your code, your JavaScript code that you downloaded, was actually used to render the page. And so here for the Alexa Top 10, we see on average 250K of JavaScript is downloaded, but only 26% of that was executed by the time of the onload event. Anything executed after the onload event could have been lazy loaded, could have been deferred to get progressive enhancement to promote progressive rendering, right? So what's this 74% of other code? It could be cases, conditions that I didn't trigger, error cases, or maybe I'm a special user or something like that. Certainly, if it's my code, there's a lot of cruft in there that I never cleaned out. But a lot of it, especially for today's websites, is this enhanced functionality. These drop-down menus, pop-up divs, AJAX requests, things like that, that could have been deferred to get the main part of the page, the main content of the page, delivered to the user more quickly. So that's the first rule, is splitting the initial payload. Figure out what of your JavaScript is needed to render the main content of the page and defer everything else. This isn't as easy as it sounds, or it might be for you. If you have a lot of JavaScript and you have a lot of developers working on that JavaScript, it can get really, really hard to unravel that code and figure out what needs to be in the initial download and what can be deferred. So there's this tool, PageSpeed, that will actually list all the functions that weren't called. And so that could be a starting point. It's not guaranteed to be 100% accurate, but it's probably 80 to 90% accurate. And if someone who is familiar with the code looked at that breakout, they could say, oh, well, we also need this error condition code down in the initial part and get it right. And there's also this tool, Delato, from Microsoft that was written up about 2 years ago, and the code was just released about 3 months ago publicly. But we're still going to load scripts as the main part of the page. How can we do that with less pain? So before I didn't show MSN, and actually this screen capture I did about 2 years ago, so they've been doing this for a while on a major portal. We see they have 3 scripts that are all downloading in parallel, and this is IE7. And in addition, they have style sheets that are downloading in parallel as well. How do they do this? Is it some secret technology that they have that we have no hope of ever unraveling? Or could we just look at their document source and see what they're doing? So they're doing document.createElement script, set the source, and append it to head, right? So it's very straightforward. I call this the script DOM element approach. So when I saw this, I started talking to other developers, doing a little poking around myself, and I came up with these 6 techniques that I wrote up in the book. For all of these techniques, we'll load scripts in parallel without blocking other requests. The 2, just for the sake of time, I'll just talk about 2 really quickly. xhreval, do an XML HTTP request for your JavaScript file. When you get the response, eval it. The downside of this is you have the same domain restriction, and you might have to massage your script a little bit if you have to have some backslashes in there, some carriage returns or something like that. Script DOM element for loading scripts asynchronously, I think, is the most popular technique that I see out there. Well, actually, that's not true. The most popular technique is document.write, which is the worst technique. It only has very limited async capability. But it's the most popular because it's prevalent in the world of ads. But for developers who are trying, and they don't even use that technique for async loading, they do it for other purposes. But for developers who are trying to take advantage of async script loading, script DOM element is the most typical technique that I see used out there. So there's no same site restriction. You can use your .js file just the way it is now. You have to be a little careful because although in Firefox and some other browsers, the order of script execution is preserved, in IE and I think Chrome and Safari, it's not. So if you use this technique on 2 scripts and A and B depends on A, but A is 100K and B is 10K, so B comes back first. In IE, if you use these techniques without any coupling, B would be executed first, and you'd probably get some undefined symbol errors. So you have to be a little careful there, and in my book I go into excruciating detail about when these situations arise and how you can couple scripts and chain them together. And then the work that Kyle is doing in Lab.js is beautiful because he's implementing that in a package that we can all use. I wanted to point out two techniques that have just come up in the last month or so. The Gmail mobile guys wrote an awesome blog post about what they're doing for Gmail on mobile devices where latency is even a bigger issue. So Gmail has a lot of functionality that isn't used to render the page. In fact, it may never be used. It all depends on what the user clicks on, right? On what the user what features the user tries to take advantage of. So they face this situation of they want to render the main part of Gmail, and then they want to defer the loading of this other JavaScript. But if you just defer it until like after the onload event, and then you download another, I don't know what it is, 300K of JavaScript, even if you gzip that JavaScript, it's still 300K that has to be parsed and executed. And guess what it does? It locks the UI thread. So all of us have experienced that when you're downloading something big like Gmail or Facebook or something like that, and you go to click on it and there's no response. I especially love it when the little spinning logo in the tab stops spinning. Then you know you're really got a locked UI thread. So they didn't want to just like defer it and then download 300K of JavaScript and have the UI block. So what they did was they put the JavaScript code in these script blocks surrounded by comments, and they defer the download of it, right? They do that after the main content has been rendered. But then they don't have to actually incur the parsing pain unless the user actually enables that feature, exercises that feature. So they just get the script DOM elements text, remove the comments, and eval it. So it sounds pretty like weird, but Google's really committed to making things as fast as possible, and they're doing this on a really popular web app. So it's a solid technique. They do it. I think they put these script blocks in the HTML document itself. If it was me and I was using this for a website, I would put them in an iframe so I could have that be cached. And then Charles Jolly, I've been going back and forth with him for the last month or so. He looked at that a different way and said, well, I'm doing a little bit of extra work there, getting it as a comment. The JavaScript parser still parses that one character at a time, even though the whole thing is a comment. So there's some pain there. And then I'm going to eval it. So there's, again, another set of parsing that has to happen. What if I just get it as a string, right? And then as the user takes advantage of a feature, I just know which module that feature is associated with, and I eval that string. So he did a really good set of experiments and posted the results. And it's not surprising. Here we're just looking at download time. And so it's not surprising that the technique of either green or blue of doing it as a comment or a string are much faster than actually downloading it as a script and incurring the parsing time. So he's got another wave of experiments that hopefully will come out soon, where he adds the parsing time for the other string and comment techniques. And I think what we're going to see is it actually takes longer to download JavaScript as a comment or a string and then eval it. But the point here is we're not doing this on the core JavaScript in our pages. We're doing it on the JavaScript that is for enhancing the page, for later functionality. And so getting it down in the page and incurring as little pain and UI locking as possible is really key. So I think that's a really good technique. So there are all these techniques out there. How do you remember them all? How do you know which ones you're not using and which ones you are using? So there's YSlow. It started with 13 rules that I put in it. Now it's up to like 25 or 30 rules. So definitely run YSlow on your pages. PageSpeed, how many people run YSlow? Okay, PageSpeed came out about 3 months ago. How many people use PageSpeed? Yeah, so it's kind of newer, and there's no one really evangelizing it that much. But it's got some really good, it's very similar to YSlow. It's a Firebug plugin. It's got 30 rules or something like that. It automatically tells you what you're doing well and not well in your page. For me, when I'm analyzing a page, I run both, and this is why. There's a lot of rules that they both measure, but YSlow has some, like especially eTag sprites, that only it measures, and PageSpeed doesn't. And PageSpeed has some really critical ones like unused JavaScript, unused CSS, that YSlow doesn't measure. So if you run both, it's not that painful. They're both in Firebug. They're both tabs. Just click on it to run. You'll make sure that you get coverage of all of the performance best practices that are automated out there right now. So with all of these books and techniques and evangelism and automated tools, I kind of envision this world where I would have this stream of flowing web performance techniques, and the horses would come up to the water and just lap it up and adopt all these techniques, and we'd have a faster internet out there. And I'm not seeing that, and instead I kind of feel like this, like I'm the performance cop, and I have to go around and find these horses and drag them kicking and screaming to this stream and force them to drink the water. And so I thought, why is that? And what I heard from a lot of developers is that they want to make code fast. Like, I think that's something that makes you be a developer, is you care about speed and optimization and writing optimal code. But the marketing people or the product people or the sales people won't let me prioritize performance because it's not a wow factor. So I thought, okay, developers want to do this. How can I get the rest of the company to get on board? So for the Velocity conference last year, I set a theme of how performance impacts the bottom line of the business. And I was really pleased to see some big players come up and pony up some stats about how performance impacted their websites. So Google Search came out and said they did an experiment where they injected a 400 millisecond delay in certain users, a very small percentage of users. And for those users, they saw searches go down 0.6%. Yahoo did a similar experiment at 400 milliseconds. They saw a 5 to 9% drop off in full page traffic. Bing got up, they took the experiment to 2 seconds, and when they got up to that level, revenue per user dropped 4%. Shopzilla went through a major optimization redesign. They went from 7 seconds to 2 seconds of load time, and their revenue went up 7 to 12%, and this is the other side of this optimization coin. When you not only get a better user experience and better revenue metrics, but you also reduce your operating costs. So in their case, they cut the number of servers needed to run the website in half. And a similar stat from Netflix, when they finally turned on gzip compression, their outbound traffic dropped by 43%. So here are some more charts. This is the Google data, and not surprisingly, as that delay was incremented up to 400 milliseconds, it had a greater and greater negative impact on searches per user. Here's the Bing data. So I threw up the revenue stat, but they also have page view stats and things like that. And here's this Netflix chart. You can see where they pushed the Apache config that turned on gzip compression. The folks in the ops group paged Bill Scott, who runs the UI team there, and told him the site must be down. All they were serving were error pages, because that's about how much bandwidth you would need to serve error pages to every user. And he said, no, we just turned on gzip compression. So anyone who runs a large website and knows what the bandwidth costs are can appreciate cutting your bandwidth cost by 43%. So fast performance, it gives us a better user experience, more traffic, better user metrics, more revenue, reduces our operating costs, our hardware costs. So why don't more people do it? It's too hard, right? It's really, really hard. So, let's see if this works. Okay, I have a mic. Oh, really? Okay, audio. Does this work? Can I pull it if I... Awesome. Now watch, the Wi-Fi will be down. Okay, here, we'll try it. Oh, and I better turn off mute. Oh, I'm going to crank this up. Oh, that sounded kind of loud. Okay, we'll see what happens. Anyone know what this movie is? Oh, A League of Their Own, okay. I should have covered that up.
It just got too hard.
It's supposed to be hard. If it wasn't hard, everyone would do it. The hard is what makes it great.
I love that. The hard is what makes it great, right? So that's why we like writing code, right? We like tackling these hard problems, especially the people here, right? I love a hard fight. I love working hard. But Tom Hanks, Jimmy Dugan, said something right before that is really more relevant. If it wasn't hard, everyone would do it. I don't want just 1% of the web developers in the world writing fast websites. I want everyone building fast websites. How are we going to make that happen? So the theme for Velocity this year, fast by default. So I want to throw up a couple examples of this. There's a company in New Zealand called Aptimize. They have a web accelerator they call Wax. It concatenates scripts, style sheets, creates sprites, inserts data URIs, makes sure you have a far future expires header, minifies, and it does all of this automatically in real time. It's an Apache and IIS software module. You install it, you generate your HTML just the way you are now. Before it leaves the box, all of these fix-ups are applied, right? They installed it on SharePoint.Microsoft.com. The number of requests for an empty cache went from 96 to 35. For a prime cache, went from 50 down to 9. The pages got about 50% faster for an empty cache and about 30% faster for a prime cache, just by installing a server module. Strange Loop Networks has a similar accelerator. It's a hardware appliance. They released a blog post about a month ago, and they said they ran it on a typical e-commerce site. They didn't say who it was. For half the users, they turned on the appliance. For the other half, they left it off. So the people who had the accelerated experience, pages per visit went from 11 to 16. Time on the site went from 24 to 30, which is kind of surprising, right? They're getting a faster experience, but they're spending more time. Why is that? It's a better user experience. And more importantly, for those people in product and business and sales, conversions went up 16%, order value went up 5.5%. So we're seeing appliances from vendors like that, but we also need to embed this fast by default mentality into the frameworks that we're using, into the CMSs and programming web development environments that we have. So I've been working recently with Yehuda Katz from the Rails community, and he was explaining to me all the things that Rails does automatically. Make sure you have far future expires header, concatenates scripts, provides for domain sharding, configures e-tags. The main thing he and I are working on is making the script loading in Rails adopt some of these async techniques, but he also mentioned coming up is spriting minification and document flushing. Sprout Core was mentioned earlier today. I've been working with Charles Jolly there, and again, Sprout Core is the JavaScript framework behind MobileMe. So he was describing to me all the things that Sprout Core is doing, concatenating scripts and style sheets, making sure style sheets are at the top, scripts at the bottom, removing duplicate scripts, similar things. So I think that we're going to see more and more of this. I'm certainly going to try to encourage it by highlighting companies and projects that are making their frameworks fast by default at Velocity this year. If anyone here has a framework, and I know people do, and I already heard some of this weekend, but I encourage you to add more fast by default functionality so that anyone using your framework gets fast websites just out of the box, just by default. So I'm wrapping up. I wanted to talk about some recent news, recent projects. So, is Francisco here? So he scares me a little bit. He's so smart. And so yesterday he talked about how sprites are bad and data URIs are good. So I feel a little funny getting up and talking about SpriteMe. I certainly think his environment maybe is a little different, and data URIs I certainly evangelize, but I think for another year or so, we're still going to need to deploy sprites. So let me see if the internet is working, if I can do a quick demo of that. How many people here have run SpriteMe? Good. Good that it's so tiny. Thanks to the 3 of you that raised your hands. Okay, so let's see. It's a bookmarklet, so it runs in all browsers. eBay used to be my canonical example. In fact, if you look here, you can see that they had all of these background images, and SpriteMe found 2, these are the slides. SpriteMe found 2 sprites to create. So when SpriteMe first came out, I emailed it to the performance guy I know at eBay, and I said, oh, you guys have some opportunity here. And they've actually, since that time, sometime in the last month, have deployed a lot more sprites. But right now, SpriteMe still finds these opportunities for creating sprites. So with SpriteMe, you can actually you can just see what CSS backgrounds are being used now. You can open it up and you can hover over an element and you can actually see where a CSS background is being used. You can just click on Make Sprite, and what it's doing is sending all those URLs off to another open source project called Cool Runnings, and getting back a, okay. And it gets back a sprited image and actually injects it in the page right now and changes all of the CSS. And then you can export that CSS and save that image so you can actually verify that it's working on your site. So that's SpriteMe. BrowserScope came out about a month or 2 ago. This is based off something I built a year ago called UA Profiler. So when Chrome came out a year ago, Dion asked me if I was going to write a blog post about how good or bad it was when it came to performance. And it was the weekend before it came out, and so I had to find the internal link for the download so I could review it and write the blog post for the launch. And I couldn't find that internal link. So I said, okay, what I'll do is I'll write a bunch of tests to measure Chrome's performance. And then when it comes out, when I go to work on Monday, I'll install it and run it through the test really quick so I can write the blog post really quick. And once I built these tests, I thought, oh, well, any browser could be run through these tests. So I created this framework out of it. And then my office mate, Lindsay Simon, took that and has started this open source project called BrowserScope. And so the original tests that I had are here in the network tab, but we've also added ACID3, Selectors API, rich text edit controls. I think next week we're launching a security module. We've got one in the work for cookies in HTML5. And basically you go to the website and we don't run any tests. All the tests are generated by you people. So anyone with a web client that supports JavaScript can navigate to the site, click on this how does your browser compare button, run the test, and the data gets stored in our database. So we have about 30,000 people who have run tests across maybe 200 or 300 unique browsers. And so it's a great resource for developers to know what the browser they're working on does and does not support. But then also it kind of highlights to the browser vendors what they're doing well and what they need to improve on. So try to keep that heat under them to give users a better browser experience. The HTTP archive format, so I want to create this repository that stores performance information for the entire internet. And I realized, I've had this idea for a couple of years, and I realized a key component was an industry standard way of saving performance data for a web page. And so in January, Hansa from the Firebug team, who owns NetPanel, said he was going to work on an export feature. So I told him he should hook up with Simon Perkins of HTTP Watch, who already did exporting, but in a proprietary format, and get them to agree on an open source format. And if Firebug NetPanel and HTTP Watch, who are both very popular have a way of exporting and importing data that it would get adopted as an industry standard. And I think we're seeing that happen. So my contributions to this project were twofold. I introduced Hansa and Simon, and I chose the 3-letter suffix for the file names. I'm serious. So it actually works now. You have to get a nightly build of Firefox to get export to work in Firebug, but if you read my blog, you can see that. And then the last thing I wanted to mention, I wouldn't plug stuff, just for the commercial value of plugging it. I think Velocity is a really good resource if you care about web performance. And we're going to start doing webinars maybe like once a quarter. So the first one of these is December 8th. It's 9 to about noon Pacific time. And we're going to have someone from Strange Loop there talk. They were the ones who ran that study about the typical e-commerce sites. So he's going to dig into those stats a little bit more. Charles Jolly from Sprout Core is going to talk about the more recent results he has about that JavaScript loading. There's going to be a cool thing from Google to talk about. Artur Bergman is going to talk about stuff more on the ops side. And we'll have, I think, kind of a high-level talk. I think it's going to be from Chris Anderson, not Damien, of CouchDB. So what are the takeaways? Focus on the front end. Don't stop focusing on the back end, but I think we've had a disproportionate amount of our performance optimization resources focusing on the back end, and when in reality, the front end is where we have the most room for improvement. So make sure that you're getting an appropriate amount of focus on the front end. Run Slow and PageSpeed. You really need to run both of them to get a full coverage of the performance optimizations that are well known. And I think really look at how you're rendering your page and make sure you're not doing too much in JavaScript for the initial user experience. Try to do as much of that server-side in HTML as possible. And I really think already now in the search marketplace, but I think in other marketplaces, we're going to see speed become a competitive advantage. So I really recommend that you start adopting these performance best practices before one of your competitors does and passes you by. Thank you. So if there are any questions, I'd be happy to take questions. And if we run out of time, I'll be here, forever. So, are there any questions now? All right, thank you.